This is third lecture of subject engineering hydrology. In last two classes, I told you the different forms of precipitations, types of precipitation, and in first class I told you some applications, overview of subject engineering hydrology. Okay. Different types of the precipitation I told you in last class, and today I am going to deliver you how to measure that precipitation, Okay. So, the objective of today's class is the measurement of precipitation. Okay. Precipitation is measured as a vertical depth, of water, What it means? If this is the ground level, okay, and it is a plain ground level. So, and if the water is precipitation is there. So, the depth of the water, okay, depth of the water, say that this is the h, okay. So, depth of the water received at some particular area, or catchment, vertical depth that would accumulate over a level ground, okay. Means you need to have a level ground. If precipitation is retained, if the precipitation is retained means what? If the precipitation is retained means there should be the provision of retention, okay. Otherwise what will happen? This precipitation is going to run off, or it is infiltrated, different losses will be there, but the water has to be retained. So, no part of the water is going either inside, okay, in the ground, or in taking part of the runoff, any type of runoff, free from any losses, okay. So, that precipitation we have to measure. Means what we have to measure? We have to measure this h. Okay. Suppose the area of the cross sectional area of this this location is A. That the quantity of the water which has been stored within this container will be what? A into h. Okay. Say A in meter square, and h suppose in centimeter, okay, suppose centimeter. So, the quantity of the water, this is the quantity of the water in unit meter cube, okay. So, when this quantity of water, is divided by divided by area, then we will get what? We will get 100 h by 100, and h is centimeter. So, this is the procedure. To record the precipitation, and the container whatever we have that are based on the different easiness to use, and different they are based on the different climatic conditions, okay. Depends upon the forms of the precipitations, okay. So, in the next slide we will be covering different types of recording rain gauges, okay. These are called as rain gauges actually, okay. So, h, what we need to calculate? What we need to record? We need to record this vertical depth, that has been stored within the rain gauges, and within the container of the rain gauge, okay. It is expressed in mm or centimeter. Okay. precipitation is measured by using device rain gauges, okay, by using rain gauges, okay. Rain gauges, I told you that they are the container, to retain the water, and that water should be free from any type of losses, okay, and these rain gauges also known as ombrometers, pulviometers and hytometers, okay. These are the different names, names of the rain gauges, okay, that you have to remember, that is asked in different objective questions, okay. So, types of the rain gauges, okay. So, we have basically two type of rain gauges, okay. First one is non-recording type of rain gauge, second one is recording type of gauge. What is the difference between non-recording and recording? Non-recording means variation of the precipitation, okay, I, okay, precipitation I with reference to time, okay. Say for example, at time t is equal to 0, say this is 2, this is 4, this is 6, this is 8, this is 10, okay. Say this is in hours. So, at particular say at time t is equal to 0, no precipitation is there, yeah, say this one precipitation is there, okay. At time 2 hours, say precipitation, this one is a precipitation, say 4, same precipitation we have, different, okay. So, different graph we will have, okay. So, and if we are observing, if we are interested to record, the quantity, we are interested to record the variation of the precipitation during that interval also, okay. Recording of the precipitation after some interval, it is another thing, What we will do? We will put the rain gauges, we will put the container of the rain gauges for some particular time interval, we will collect it, and then we will measure the quantity and calculate the rainfall at one particular time interval. But if we are interested to record the variation of the precipitation within a very small interval of time, then that is that type of features incorporated with the rain gauge are known as recording type of rain gauges, okay. With this feature, of recording variation of the rainfall within a short duration, that is that are recording type of rain gauges, and non-recording means simply collection of the water at some particular time interval, then calculate it, okay. We have for non-recording type of rain gauges, we have two rain gauges, Syphon's and Indian standards rain gauges, okay. Syphon's rain gauge, and for recording type of we have certain 4 type of rain gauges which are in use, okay. Weighing bucket type rain gauge, tripping bucket type rain gauges, Syphon's Syphon rain gauges is a floating type radar measurement, okay. I will show you pictures so that you can imagine that how it will be taking place to record the precipitation within that interval, okay. So, first of all let us take this one, okay, Syphon's rain gauge, okay. In Syphon's rain gauge, this type of arrangement is there, okay. And you know that which type of this is a non-recording type of rain gauge, okay, non-recording type of rain gauge. So, we have only container, and in container we can record, we can store a water, up to 1 to 2 liter, okay, 1 to 2 liter of water that can be stored, okay, and and at the top of the that container, that of the container, there is a funnel, with the diameter of 12.7, with the diameter of 12.7 centimeter. Okay. And water and the precipitation, okay, the precipitation that has to be stored, that has to be stored with that collector. Okay, with that is known as a collector. Okay, the water has to be collected over that through this funnel, and the water is coming here, coming in this container, that is a receiver. Okay, that is used to find the depth of the precipitation. Okay, and its height is mentioned here. Its height is 30 centimeter. Okay, 30 centimeter. It is mounted on a concrete, basically concrete block of this dimension. Okay, of this dimension. Okay, so this is the rain gauge given by the Siemens, and this is a very common. That's why it is a universal gauge. That's why it is a universal gauge. It's a use, it's a utility, it's a way of use, method of use, procedure to record is a very simple. So it's a universal. Diameter of the collector, I told you, it's a 12.7 centimeter. Okay, that has to be remembered, because this is a part of the two type of questions. Again, the next thing is it can measures, it can measure 100 centimeter to 175 rain at a time. It can it's a capacity, it's the capacity 12.7, 1 to 2 liter. The container are designed in such a manner that are able to record the precipitation in the range of 100 to 175 right. And the depth of the rain, okay, in centimeter or it is very simple. It is how it will be calculated. It is the ratio of volume of the water collected by the gauge, means in that container what is the volume of the water divided by the cross sectional area of the collector, what is the whatsoever is the cross sectional area. So the ratio between these gives you the depth of the rain. Okay. The next non-recording type of rain gauge, that is a IS rain gauge. Okay. In IS rain gauge, this Indian standard rain gauge to match Indian conditions. Okay. There is some differences. Okay, some dimensions. This dimension, okay, that has been modified, that are modified. Okay, depending upon our Indian conditions. Okay, Indian conditions, the dimensions has been modified. Okay, similar to Siemens gauge, width of the following modification. Okay, cross sectional area, it is 100 centimeter square to 200 centimeter square. Okay, 100 centimeter, that has been changed to receiver capacity 2 to 10 liter. Okay, that is increased, and metal container, that has been replaced with fiber reinforced plastics. Okay, so these are the changes over the Siemens rain gauge, and after the modification, that is basically our Indian standard rain gauge. Okay. And fiber reinforced plastic container. Okay, that container actually measures 100 to 1000 as compared to in previous it was 100 to only 175. Okay, it was in previous in Siemens rain gauge it was 175, but that IS rain gauge it can measure 1000 precipitation at a time also. Okay, and measurement is recorded at so manually is no problem. Okay, so this is the these two the are non-recording type of. The next I will tell you different rain gauges which can record the precipitation also. Okay. First one is weighing bucket type rain gauge, weighing bucket type rain gauge. Okay. What is the concept behind these rain gauges? The concept behind these rain gauges are very simple. Okay, very simple. Okay, look here, look here, look here. Okay, this is the container. Yeah, you in this shape, and it is a springly attached. Okay, and when the water with this one intensity, okay, 0.25, okay, dimensions are selected in such a manner that this much quantity of the water gives its weight in such a way that it turns down. Okay, and in turning down, the weight is the water, okay, known quantity of the water, okay, the time and the known quantity of the water has been recorded, has been noted, okay, through this. Okay, this is the pin jointed type of thing, and rotation will possible at rotation is possible only at certain quantity of the weight of the water, okay, stored in this area. Okay. So, this is that's why it is a weighing bucket type. Okay. When the main quantity of the water, okay, is collected in this container, then it is being tipped up, and during the tipping, okay, that side will record on the paper. Okay, that will mark on the paper like this. Okay. So, this is the container, weighing machine type of arrangement is here, arrange type of, and after tripping, this pointer records in a graph like this manner. Okay, this pointer has been attached to record that the time. Okay. So, this is the arrangement. Okay, this is the arrangement tipping bucket. Okay, the quantity of the water that is being tripped in this. Okay. So, this type of rain gauge is used to measure rainfall at remote and inaccessible location. Okay, it can be it is capable to record the precipitation, right. Tips for every 2.5 mm rain water collection that I have told you. Okay, for this one quantity of the water that has to be tipped up, and due to with the help of the pointer attached other side, that is recorded. Okay, so this is okay. This is the weighing bucket type rain gauge. Okay, no problem. This is very, and this is another tipping bucket type rain gauge. Okay. But the concept behind both are same. Okay, here the arrangement is the pointer is here. That pointer gives you the mark in the graph paper. Okay, it is tipping bucket type rain gauge. It is weighing bucket type rain gauge. Okay, weighing bucket type of rain gauge. Okay, so the quantity of the water. Okay, the quantity of the water at some particular duration. Okay, that gives you the amount. Okay, the quantity of the weight collected, the quantity of the precipitation, the quantity of the known quantity of the means 2.5 mm 2.5 mm quantity of the precipitation recorded in particular time interval, that has been recorded by this one and by this one. Okay. So, here is a platform bucket, is a weighing machine is over here. So, as soon as the water is coming over here, that weighing machine mechanism through a spring, it is moving in upward and downward direction. So, we have recording here, Okay. So, tipping bucket, this is rain gauge. Okay. Simultaneous recording is also there. Okay. Syphon's rain gauge. Okay. Syphon's rain gauge under normal conditions. Okay. This is a pointer attached with this floating body. Okay. Rain is coming inside through this funnel. Rain is coming through this funnel. Okay. Once okay, then is coming to here. Okay. So, due to this the arrangement, floating type of arrangement with the pointer, okay, with the pointer, okay, with the pointer. Say at this one depth, of the water, okay, this one depth of the water, the floater will be here and the point mark will be somewhere downward, okay, and as long as the water is coming here, the floater will be in upward direction, and that is why recording will be here. Okay. So, this is the Syphon's type of gauge, okay, rain gauges prefer and this is preferred to other gauges as per Indian Standard Code. Okay. The next type of rain gauge recorder rain gauges are the radar measurement. Okay. We are using radio detection and ranging technology to record the rain gauge also. Okay. But that system is different. Okay. It is not the precipitation is not recorded at a location. Okay. The precipitation it is recorded within an area, actually within an area, okay, not at the at particular location, right. So, it measures the rainfall over an area, whereas other rain gauge measures the rainfall at a point. Receivers, different mechanisms are there. So, go through the books for details of that. Okay. So, the next thing rain gauge stations. What are the rain gauge stations? Okay. What are the rain gauge stations? Rain gauge stations are required. Sufficient rain gauge stations are required to have exact assessment of the precipitation. Okay. If we have a smaller number of rain gauges, if we do not have the sufficient number of rain gauges, then we will not have the real representation of the precipitation over that catchment area. So, rain gauge stations, what are the rain gauge stations? Rain gauge stations are the place where rain gauge is installed, okay, where rain gauge station is installed and rainfall measurement is carried out, okay, it's called rain gauge station, okay, rain gauge station simply, okay, rain gauge station, okay, and prior to install the rain gauge station, okay, one some precaution has to be there, means what are the precautions? Precaution is that the building, say for an example, this is the location of the this is the horizontal surface and this is the location of the rain gauge station, okay. So, and say there is a building or any obstacle of certain height h, okay, then the minimum horizontal distance that must be double times of that height, okay, that care must be taken, okay, to every side. Suppose if at small h distance here, okay, so small 2h at every in radial direction that must be care of prior to install the rain gauge station at any position, and it's a minimum plot area. The second thing is the minimum plot size, okay, it is a 5.5 into 5.5 5.5 meter into 5.5 meter, that is the area required, okay. Level ground, second one thing, level ground open to sky is required, okay, okay, and minimum distance between the gauge and nearest tall object is 30 meter, okay, minimum distance between the gauge and nearest tall is 30 mm. Okay. For this distance 2h are 30 meter, okay, or 30 meter on both side. Okay, means from 30 meter to this, from 2 meter to this, no one building will be here, and if the building is here, then double times of its height should be the horizontal distance, right. So, please remember it, okay, 30 meter or 2 times of h, the condition for installing the rain gauge station. Okay. Rain gauge density, next is rain gauge density. What are the rain gauge density? The rain gauge density are the number of rain gauges. These are the number of rain gauges given number of rain gauges per given area. Per given area is called the rain gauge density. Okay. So, say for example, the area is A. Okay. Area is A, and we have total number of rain gauges. Number of rain gauges is equal to n. So, what will be the density? Density will be n by A. Okay. If n value of n is more for constant area, then it will be then the higher value shows that we have more number of rain gauges in that particular area. Okay. So, there are some thumb rule, to have the number of rain gauges in some particular area. Say for an example, for plain and flat catchment, okay, for plain and flat catchment, one rain gauge for the area of 520 kilometer square, that has been recommended. Okay. For elevated areas above 1000 meter, one rain gauge for 260 to 390 kilometer square, that has been recommended, right. And similarly, for mountainous and hilly regions, okay, for every 130 kilometer square of area, one rain gauge is recommended, right. Now, how to find the optimum rain gauge stations? Okay, the next question is that how to find the optimum. Say for an example, okay, because that is not the fixed rule. Okay, this is the thumb rule only. But if we want to find the optimum number of rain gauges, then the optimum number of rain gauges can be calculated with the help of that expression. What is that expression? What is the meaning of that expression? It is a very simple. Okay, find the mean rainfall of the data. Mean rainfall of the data at different stations. Say 1, 2, 3, and so on m. Okay, so find the mean rainfall data, and after having the mean rainfall data, you find the standard deviation with the help of that expression. Okay, and it is the summation of pi minus p square divided by m minus 1. And if we know that standard deviation, then you find the coefficient of variation. Coefficient of variation is 100 times of standard deviation divided by p mean. Okay, p mean that has been recorded by the rain gauges. Okay, and this CV, square of this CV, ratio of this CV by percentage of error gives you the number of the rain gauges, optimum number of the rain gauges. Let us see an okay, these are the factors. N is directly inversely proportional to E, and it means accuracy. Okay, these are the various parameters that you can go through that study. Now, let us take one example. If the average precipitation at some catchment area, it is 92.8, and standard deviation that has been and 10% of error we have taken, then value of CV it is 33.08, and then N is calculated as 10.94, means 11 station should be the optimum. Okay, for this one CV 33 CV 33%, n is equal to 5. What is the permissible error? It is 15.76. Okay. One more thing is the remaining is that additional rain gauge required. Additional rain gauge is required. Okay. Additional rain gauge required is m minus n. Okay. Suppose we have calculated this one value as here as 15 we have calculated, and the recorded this is n minus m, and recorded data it is at m number of locations. Say here it is 4 places the rainfall data has been recorded, and we have calculated 15. So 11 stations we need to add one more. Okay. So that's for today. So in next class we will be discussing next topic, okay, of unit 1 of KTU syllabus. Okay. Thank you very much.